So this is just a continuation from our first video on logs. So question 7, express the following then in terms of log A, log B and log C. So this is just where you are being asked to expand things out. So the first thing I'm going to do is the square root of BC. Well, we know the square root is power of a half. And if both B and C are underneath that, that's B to the power of a half, C to the power of a half. Then I'm going to say, well, these are all multiplied together, so we know using our rules of logs, then we can expand that out as log of A squared plus the log of B to the power of a half plus the log of C to the power of a half. And then I can bring all my powers down. So 2 log A plus a half log B plus a half log C. Part B then, 4 log of B cubed over the 4th root of C. So I'll keep a 4 out. And then it's the log of a quotient, so we're dividing, so we'll take away. So that's the log of B cubed minus the log of the 4th root of C. So the 4th root of C is the same as C to the power of a quarter. Bring down our powers then, so we'll get 3 log B minus a half log C. And now just multiply n by 4, so we get 12 log B. 4 times a quarter obviously gives us 1, so it's just minus log C. Question 8 then. So A is log 3 and B is log 5, and we want to express the following in terms of A and B. So the first thing we have is the log of 15. So we need to see how can we write that in terms of log 3 and log 5. So hopefully it should be obvious that 15 is 3 times 5. I can then write that as the log of 3 plus the log of 5. And then the log of 3 is A and the log of 5 is B. So we can write that as A plus B. Part B then, the log of 0.6. With the majority of logs questions, you're better working in fractions as opposed to decimals. So 0.6 is 3/5, and then again it should be fairly clear. We can write that as the log of 3 minus the log of 5, and the log of 3 is A and the log of 5 is B, so that's A minus B. A wee bit more complicated then, the log of 75. Look for prime numbers, prime factors. So in junior school, you would have had to have written out 75 in terms of prime factors. Now you can use the wee factor button in your calculator if you can't see it straight away, or you can say, well, 75 divided by 3 is 25. 5 into 25 goes 5 times. 5 into 5 goes once. So hopefully you can remember that from junior school. So we can write that as 3 by 5 squared. So we can expand that out to the log of 3 plus the log of 5 squared. Take our squared down, and we get the log of 3 plus 2 log 5. Then we know that the log of 3 is A and the log of 5 is B, so we get A plus 2B. Part D then, the log of 30 plus the log of 45, and again we're trying to express this in terms of A and B. So I'm going to just take them each in turn. Now, we want to get things in terms of 3 and 5, but we can also use 10, because remember we're working in log with no base written in, which means the log to the base 10. So I'm going to change 30 to 3 by 10, and I'm going to change 45 using my prime factors. I could write as 3 squared by 5. So then when I expand each one, the log of 3 times 10 is the log of 3 plus the log of 10. And our log of 3 squared times 5 is the log of 3 squared plus the log of 5. I'll bring my 2 down then. So then 2 log 3 plus log 5. Now we've got 1 log 3 plus 2 log 3, so we've got 3 log 3s plus your log 10 plus your log 5. So log 3 was a, that's straightforward enough. The log of 10 to the base 10, so the log of anything to the same base, remember, is 1. And then the log of 5 is b. Our last type of questions in this wee video is equations that we'll have to solve involving logs. So our first one is the log of x to the base 5 minus the log of 2x minus 3 to the base 5 equals 2. So the first thing I'm going to do is combine those. It's a minus, so it's x over 2x minus 3, and that's going to equal 2. And we can rewrite that as x over 2x minus 3 equals 5 squared. So I'm bringing the base up to here and kicking the 2 on up. So that equals 25. I can bring then 2x minus 3 across, and now it just becomes any type of equation that you would solve. So x equals 75 over 49. Part B then, completely different type of question. 2 to the power of x equals 20. At the start of the year, you would have had questions like 2 to the power of x equals 16, where we could write both sides as 2 to the power of something, but we can't do that with 20. So if you can do it using your indices, and sometimes the question will tell you to use indices to find x, but we're going to take logs for this type of question where we can't write it all to the same base. So we've got the log of 2 to the power of x equals the log of 20. So take down our x. So the x log 2 equals log 20. So x is log 20 divided by log 2, and do that in your calculator. Now just be careful when you're using your calculator. Some will open up brackets after the log, and you need to make sure you close them again. It depends on the type of calculator you have. So try that in your calculator, and you should get 4.32 to 3 significant figures. Okay, C then. So the log to the base 2 of 32x minus the log to the base 2 of x squared over 2 equals a half. So the first thing I'm going to do is combine our logs. So it's divide. So we're dividing 32x by x squared over 2. And when we do that, we get 64 over x equals a half. So I can write that then as 64 over x equals 2 to the power of a half. Now, there's a couple of different ways you can do this. You can say, okay, well, 64 then equals 2 to the power of a half times x. So 64 divided by 2 to the power of a half equals x, which gives us 45.3 to 3 significant figures. If you want to, I probably would make things awkward for yourself, write that as 2 to the power of 6 equals 2 to the power of a half x, because 64 is 2 to the power of 6, and then I'm going to divide, and I get x is 2 to the power of 5.5, or 11 over 2, which is also, see, 45.3. Three significant figures. Either one's fine. D then, 5 to the power of x equals 6 to the power of x minus 1. So powers on both sides. And we're going to take logs of both sides of the equation. So then I can bring the powers down. So we'll get x log 5 equals x minus 1 on log 6. I'm going to multiply out this bracket then. So we get x log 6 minus log 6. I'm going to then bring all my x's to one side. And then I'm going to factorize. So x upon log 5 minus log 6 equals minus log 6. So then I'm going to divide minus log 6 by that bracket, log 5 minus log 6. And when I do that, I get 9.83, three significant figures. Part A, 3 to the power of 2x minus 5 times 3 to the power of x plus 4 equals 0. So again, you've seen these questions earlier in the year when we were doing indices. Just a slight difference. So we can write 3 to the power of 2x as 3 to the power of x all squared. And then hopefully you can see this is one of these hidden quadratics. If we let y equal 3 to the power of x, we can write that as y squared minus 5y plus 4 equals 0. And obviously you can solve that no problem. That's y minus 4 upon y minus 1 equals 0. So you get y equals 4 and 1. So up to now, it's the same as the kind of indices questions you had earlier in the year. But what you did then was you'd say, well, that means 3 to the x equals 1 and 3 to the x equals 4. We can say, well, that has to be that x is 0 because 3 to the power, anything to the power of 0 is 1. But in the indices questions, you would have had something like a 9 here where you could write it as 3 squared. So in this one here, we can't, so we'll have to take logs. Bring our x down. And then divide log 4 by log 3 to get x. And it's 1.26 to 3 significant figures. Our last type then is a simultaneous equation. So this time we've got two equations with x and y in it. So our first one is log x minus log 2 equals 2 log y. And our second equation is x minus 5y plus 2 equals 0. Now you might get two equations with logs in it, or you might just get one. So I'm going to take the log equation first, and I am going to tidy that up. So we can write that as the log of x over 2 equals the log of y squared. So that means x over 2 has to equal y squared. Okay, so the log of one thing equals the log of something else. We can say that x over 2 has to equal y squared. So x is going to be 2y squared. So I'm going to then substitute that in to this equation. So where I see x, I'm going to replace it with 2y squared. So we'll get 2y squared minus 5y plus 2 equals 0. And now you just have a quadratic to solve. So you can factorize it, you can use the formula, you can use your calculator, however you want to solve it. And you get that y is a half and 2. And then substitute that back in to get your x values. So when y is a half, x is going to be 2 times a quarter. So that's a half. And when y is 2, x is going to be 2 times 4. So that's 8. And give your answer as coordinates. So you're showing which two answers to go together. Half and a half and 8 and 2.